Hi, this is Jeff Heaton. Okay, let's install GPU support with TensorFlow on a Windows computer. Now this can be a lengthy and drawn out process. I mean seriously, this is my dog after he finished the whole process. See, he's exhausted. It's really not that hard, but the thing that gets a lot of people is you install a particular version of TensorFlow. That requires a particular version of the CUDA drivers. That requires a particular version of cuDNN. Then that all requires a specific version of the CUDA toolkit and other things. So it's like a puzzle. You've got to have all these version numbers correct and correct at the point in time that you're installing it, or you're going to get errors. So I can't just give you this video and show you all the version numbers and step by step, but I'm going to show you where you get those version numbers, write them all down, and go through this installation process. And I think it takes about 20 minutes, including even load and download times. So we'll see how quickly I do it. I have a brand new instance set up and ready to go, so let's get started. And this is Jeff Heaton. Welcome to Applications of Deep Neural Networks with Washington University. To see all my videos about Kaggle, neural networks, and other AI topics, click the subscribe button and the bell next to it and select all to be notified of every new video. This is a very long video for me. Usually I don't record videos over 30 minutes, but this is the overview of this video, all the various parts of it. There's a lot to installing a GPU. So you can definitely click on the links in the description to rapidly jump to any part in this video. Okay, so the first step, and this may sound obvious, is just knowing what type of GPU you're installing this for. Now, if you installed your GPU, you're probably aware of what it is. Here you can see the Tesla K80. This is the GPU that we're going to be using for this installation. As you can see from the price here on Amazon, it's about a $934 GPU. So this is a high-end one. This is also the same one that's available on Google Colab. There's also much more high-end GPUs than this one, and you can also have multiple GPUs set up as well. Even arrays of computers with multiple GPUs. So there's a lot of options you can do there for high-performance computing. Now, where you might not know what GPU you have is if you're dealing with a mobile system like a laptop. Often these will be built of GPUs that are somewhat custom in terms of what the manufacturer put together. Microsoft is great for this on the Surface line of their laptops. Other manufacturers as well. However, the key thing here is, and this will be disappointing to some of you, you have to have an NVIDIA GPU because it makes use of CUDA. TensorFlow makes use of CUDA, therefore you have to have a NVIDIA GPU. Now there are ways to use TensorFlow with other, I believe, OpenCL environments, but that is very involved in terms of rebuilding things. I've honestly never done that. I'm not too much of a hardware guy. I tend to like to just go with the way, if the manufacturer like TensorFlow says they want CUDA, I'm going to give them CUDA. I'm not going to go through heroics to try to get AMD or something else like that working. It's just too much of a time investment. Let's also look at this GPU from the side. You can see this is a double slot card. So this takes up 2 slots in your computer. This is pretty common for even gaming GPUs. Now, one other thing that I'll note in this, I'm not building a computer around this. So I'm not talking about the hardware and how to put the actual computer together. I will actually be installing this on a Windows 10 instance running in Amazon Cloud. Now, normally you can't run Windows 10 in Amazon Cloud. I actually created my own virtual AMI and uploaded that. I could do another video entirely on that. So if you want a video on how to run Windows 10 in the cloud for this kind of stuff, let me know. I can definitely put that together. Also, can't resist trying, since I am not doing this on native hardware. If anybody from NVIDIA is watching and would like to provide me with some native hardware to try this out, I'd be glad to do a video completely on that. Definitely, let's talk. And just so that we're clear, this is the actual Amazon instance that I'm using. It's a P2X large. Again, I create my own AMI completely from scratch using a consumer your Windows 10 installed, just like if you bought Windows 10 off of Amazon. Actually, that's where I bought it. Now, I can't provide you with my AMI. I would love to, but that would violate Microsoft licenses. All right, here you can see I have a clean install of Windows 10. This is exactly like what you would install yourself. This is not a server edition. So like I said, you can't just run this off of Amazon. There's not AMIs available for this, but this lets you be able to get access to GPUs that, or at least I would not want to pay for. Now, I did install the Amazon drivers for this, so you're getting the display that they like to put up here, so you can see the AWS specific information. Don't even try to hack into me. By the time you see this, I'll already have this instance down. Not that anybody watching my channel would do such a thing. First, let's just verify what type of GPU we have installed. You might need to do this if you're on a mobile system or if you bought your computer from a vendor and you're not entirely sure what type of GPU you have. You can do this from computer management, and you go to device manager and display adapters. And here you can see I have an NVIDIA Tesla K80. Now, if you're running more of a consumer card, you'll probably most likely have a GeForce. Okay, with that established, you need to remember that, because when we're going to go and download these drivers for this, you need to know that, in particular, Tesla, the family, but also the specific driver that you have. So to make use of this, let's go ahead and go to my GitHub repositories, github.com, Jeff Heaton. Go ahead and follow me if you want to. It's a great repository, set of repositories. This is my class right here, T81 Deep Learning. I'm going to go into here, and the instructions you'll need are in the class 1.1 overview, and there's some other files that we'll need to download from here. In fact, let me just go ahead and go to the bottom of this list of files that I have. It's locking up. I hate Edge, but I'm too lazy to install Chrome. So let's go ahead and go to TensorFlow GPU, this YAML file, and then we'll click on the raw. So this is a configuration file that I have set up for installing everything that you need for my class, which is enough to really get you started with machine learning. So even if you're not following my class, this is a good set to make use of. Now you'll see that when I'm installing TensorFlow, I have TensorFlow GPU version 2.0. I always lock this version to whatever is the current one for the current semester. So you might see a later version of TensorFlow like 2.1 or beyond. You'll want to right click, can't just save as, I hate Edge. I'm going to install Chrome. We'll just fast forward through this part. And now with a decent browser installed, let's save as. I am going to save this as, and also take that out of text document, or it'll put a TXT onto the end for you, which is annoying. I also like to put quotes around it in Windows so that it doesn't add extensions on there for me. And I'm just going to download this to my user directory. We'll be using this in a moment. So now we have my installation script. Let's go here and look at class 1.1 overview. If you scroll down, I've got all of the instructions here, and I'll have a link to this on the description if you look below this video. We're going to go through the MiniConda installation and all of this stuff, also get the GPU drivers installed. We're going to start actually with the GPU drivers. So I'm going to skip past this part up here. We'll be coming back to this later. But here are the instructions for the GPU. So that's the file I just had you download. This is the instructions for GPU setup. And this is the Rubik's Cube that I was talking about before. Let's go and take a look at this. This is on TensorFlow. So here they have the GPU setup. Now they've got Windows and Linux and everything mixed together. By the way, you cannot do, not without a lot of special extra steps, you cannot do TensorFlow GPU for Mac. It's just not supported. Mainly because Mac doesn't come with NVIDIA anymore, which is unfortunate. Scroll down to where it says software requirements. I'm going to keep this open as a tab throughout this. See these version numbers? It says you have to have this installed ahead of time. This last one is optional. We'll install this last one as well, but these version numbers are critical. Where it says NVIDIA GPU drivers, CUDA 10.0 requires 4.1x or higher. It's not that TensorFlow requires this. CUDA down here requires it, which makes this one require it. So they have listed for you these version numbers. If you install even CUDA 10.1, I'm pretty sure that would mess the whole process up. You'll get these DLL errors and all kinds of pain at the end, and you can find all sorts of Stack Overflow postings where people have misaligned these and not installed exactly the version numbers asked for here. Now be careful. Don't install the version numbers that you're looking at on the video, because they will probably change only weeks after I record my video as stuff moves forward. So you'll want to go to this page on TensorFlow and use these numbers. This is the most important thing to do as far as this video is concerned. Now, I have no preconceived drivers on this machine. I just installed consumer Windows 10, so it's not like Amazon has done anything to help me. So I am going to just start from scratch, just like you would be doing. You probably have some sort of NVIDIA drivers on your machine. If you're a gamer and you're making use of a GPU that's also strong for games, that's where you're going to have to be careful. Maybe a game wants one version and another, but these are the actual GPU drivers. So there's a little bit of version problems that you can run into. And this is where NVIDIA Docker is great when you're running this in the corporate environment. So let's go ahead and download this. I am going to just put this into another tab, because I've got to keep this up. This is my survival guide. If I don't follow this, I am in deep trouble. So product type, you might have Titan or you might have GeForce if you're dealing with more consumer grade cards. I have a Tesla. Wish I had a Tesla parked in front of my house. That'd be awesome. Product series is K, because it's K80, and it even defaults to the K80. Operating system is Windows 10 64-bit. You better be running 64-bit. This does not work with 32. That applies to your Python as well. Don't do 32. If you have 32, I'm sorry, this just won't work. You might want to try Google Colab or something where you're not running it actually on your computer. Standard drivers. CUDA toolkit. This is important. Remember that survival guide that I gave you before? Don't just take the default. If you did that, you would be in for hours of Googling Stack Overflow. So go back to here just to be sure, CUDA 10.0. If this is something other than 10.0 on your real web browser in wherever you are at in the space-time continuum. I am on the second day of 2020, January, and English. Don't know what happens if you pick something other than English. That might or might not work. I suspect it would work just fine. So that's what I need for my particular GPU. I'm going to search, and it's got it here. So I'm going to now download. They've already got all this information from me 1,000 times before, so I'm going to skip and continue to download. I shall agree and download. My download happens quick. I am running on Amazon. I am literally on the backbone of the internet. So yours might go slower, but this is nice that these downloads happen very quickly for my demonstrative purposes. So I'm going to go ahead and run this. This is the first part of the installer. This is just unzipping the installer. I'll fast forward through this. All right, it's checking compatibility and such. I will give you one important point on this. If you're installing this into like a virtual machine or something such as that, a very common problem, and I've hit it a few times, if you just don't give this thing enough disk space, the installer will fail in the middle and it does not tell you out of disk space. It says GPU failure, which makes you think it's any number of 100 other things. So that's just a common gotcha. I have plenty of space for this though on this install. We will fast forward through this. Okay, I will agree. The Express setup seems to work just fine. We will fast forward through this. Okay, this is finished, and I'll warn you, if things go wrong, and I have had them go wrong here, the error messages are not good. So you'll need to check and make sure that you really had the type of graphics adapter that you thought you had, and make sure you had enough disk space, or just Google whatever error message it happens to give you. So we'll close this, and now we're back at my survival guide. Actually, TensorFlow's survival guide. Again, making sure you follow those version numbers exactly or you're in trouble. Now we're going to get the CUDA toolkit for CUDA 10.0. So click Windows. Architecture is this. We want version 10. Now I am using Windows 10. You can install this on server instances, and I'll probably do another video showing how to do this truly on a server in the cloud, AWS, and then you would pick one of these. Again, you're not going to pick the latest one because it just doesn't support it yet. So I'm doing Windows 10. Your installer type, I prefer local. That shouldn't matter. And I'm going to download it. Okay, CUDA is downloaded. Now just so you understand the progression here, previously we installed the GPU driver, so that's the same sort of thing you'd need if you were playing a video game on this. Now we've installed CUDA. CUDA is sort of the chipset inside of the graphics driver, so these are the instructions that it runs. CUDA lets you have access to execute things on your GPU. So we'll run this, and yes, we'll give it permission to run. It works very similar to the graphics driver thing that we just ran. So it's going to just unzip it there, then run the installer. Takes it a moment to unzip. We'll fast forward that. Okay, it's starting up. There's still some more waiting involved, lots of waiting with this, so let's fast forward through this. Okay, the usual agreements and such. Express is just fine on this one. I don't really do Visual Studio, but I accept this one anyway. I believe some of the Visual Studio components are used at a low level for C compilation. We will fast forward through this. All right, hopefully that all went fine. Next, I don't need to launch any of that. All right, let's go back to my survival guide. This one here, cuPTI, that was part of this, and it is part of the Express install, so that would have been covered already. If for some reason you're getting errors that this is not there, then maybe they change that in the future and you want to do a advanced install with CUDA and make sure that that is included. I can't imagine that happening, but who knows. cuDNN, this is very important. Again, NVIDIA, that's your low-level drivers. This gives you sort of, think of linear algebra on top of it and other mathematical capabilities and general programming on top of your GPU. But then cuDNN is like a library of deep neural network functions that are used not just by TensorFlow, but by many of TensorFlow's competitors that are all running on the same platform. So we need this. And here they're a little more liberal with this, but they say it must be greater than 7.4.1. So that's what we'll do. Going to launch this, and again, make it a tab, and again, 741. So we'll go over to here. We want to download cuDNN. Membership required. You do have to create an NVIDIA account and download it, so it's a subscription wall, I guess. Doesn't cost any money. I've already got one of these, so I'm going to log in. Don't sell my email address to spammers. Okay, I'm going to agree to their terms. These are, again, all the versions. So you want to make sure that you have 10.0 because that's the one that you're doing. And then that's the version number that they had. This is greater than what it was asking for, so this is good. If it was asking for an earlier one on that survival page back here, then you'd have to go to archived releases. I've never had that happen where I've had to do that. So I'm going to download this one. I want this one for Windows 10. Zip file it's downloading. So I'm going to open this as a zip file. This CUDA directory, you're going to have to manually copy this somewhere. You see this a lot with some of these advanced machine learning packages. You download them, you put it somewhere, and then you have to put it into your system path. We'll be modifying the system path in just a little bit here. Now, before I modify my system path or even copy that somewhere, let me scroll back here. Now, this is Unix instructions. It does fundamentally the same thing as what we're doing in Windows, but on Windows, they want these paths here. And we'll see several ways to create these paths. You can do a batch file that does all these sets, or you can put them right into the environmental variables like we're going to actually do. But notice where they wanted CUDA to be at. C:\tools, CUDA bin. I wish they would mention that up front in the document, but really you could put it anywhere. But again, I just want to put things in the most standard location possible. It's like the quote from Office Space, my only real motivation is not to be hassled with TPS reports. So let's just put it in that location. That seems to be the path of least resistance. I'm going to open up another Windows Explorer. I'm going to create this tools directory that they want and copy this to this. No fancy install programs. We just copy it right over. All right, this next step is absolutely critical. You mess up this step, everything else won't work, is those paths. So let's go back to that page that I keep calling my survival guide, this one. Now you have a couple of options. Probably the easiest is just to copy and paste those into a batch file and then run that batch file from the command line before you do anything else. but that's only going to have dominion in that command prompt. So I want to do this more universal. So I'm going to go to, maybe I can go right to environment. Yeah, edit system environmental variables. So I just typed environ into this search where Courtney would normally be, but I disabled Courtney when I first installed it. She annoys me. Okay, so we're going to click on the environmental variables. You can put it up here on your user ones. I prefer to put this on the system. You can see there's some already being installed for CUDA for you. That's good. That was done by those install programs. No reason to mess with that. Then you go down to the path and you edit the path. And essentially what we've got to do is add these. You don't want to add set path equals, and you don't want to add this part on the back where they're trying to chain the path. So that path, that just means that what came before it gets added to each one. All we want to do is grab these parts, so that part for each one, copy it into the control panel, and then we're going to just add it in here. Now, if you've gone through this before and you have these in here up earlier, you're going to have to delete them. So check and see if you have something like these already in there. In fact, we do. In my case, glad I mentioned that. In my case, this one was already here, so really that's a duplication. It doesn't matter, but that will bug me. So let's see. This one is not there, nor is the include, and that's an important one, by the way. And then that one. So yeah, everyone but the first one. But having one of these in there more than once won't necessarily hurt you. And again, don't get that path and don't get the first part. And then this one, and finally, and then we can say, okay. So at this point, it's functional. We have CUDA installed. We don't have TensorFlow installed yet. There's just that last step up here, optional. TensorRT. I have not done a tremendous amount with this, and this one is optional. You could get some performance improvement, but it's easy enough to install. You'll want to download it. Doesn't have as advanced of support on Windows. I've used this mainly in kind of high-end Linux-based environments, and usually where it was already installed for me, but I go ahead and download it now. Again, it's asking for a version, so be afraid. See, 5.0. So never just pick the latest. Picking the latest is bad. This stuff changes so fast that even Google can't keep up with it. So I should say the Googles and the NVIDIAs can't keep up with each other. So very rare that you'll be installing the latest of everything. So we'll get 5. This is another zip. Again, you can pick between the 5, again, these are 5.1, so stay away. Yeah, it wants 5.0. So stay away from those. GA, generally available, that's always release candidate. Be afraid sometimes. We'll get that. I always hate it when I think, okay, there's my choice, and then you click it and it reveals 50 other choices you have to read through. Of course, Windows is at the bottom. I mean, Windows gets not as much support in this world. Again, you want 10.0. So you get this one, and let's open it. It's a zip. All right, so there is that. That's where it's at. I'm going to put it to that same tools directory. So we're going to put it here. I will fast forward through this. Then you got to get your environmental variables back up. Go back to that same path we were at, and there's the changes I made before. I'm going to go into here, go into the bin directory. Actually, as I recall, this asks for the root directory because it needs to find bin and it needs to find include. Copy that to there. Okay, we have all the low-level prereqs installed. Now let's go get MiniConda. So here is MiniConda. Now at this point, the instructions are going to follow closely to my instructions for my class, just for CPU in general. You're going to want to grab the latest version of Python 3.7. Now, if this is Python 3.8, grab it. Get the latest version here, because we're going to create an environment underneath it that has whatever version of Python TensorFlow needs at the time that you're installing this. So we'll click on this one, and you've got to do 64-bit. TensorFlow does not support 32-bit. If you install 32-bit, everything will seem fine. Then you'll try to install TensorFlow, and it'll say TensorFlow doesn't exist. TensorFlow doesn't exist for 32-bit. That downloads instantaneously because I am on a AWS instance, almost on the backbone of the internet itself. Okay, we will go through this. Click Next. Agree. I do install it usually just for me. I get hassled less with security prompts later. I like this location. Sometimes it'll install it in a hidden directory under app data, but this is my preferred location for it anyway. So it's C users, J Heaton, MiniConda. This is where I vary from the path, so to speak, on path. They recommend against this, but I really like having MiniConda in the system path so that I can find it from just any DOS prompt that I ever happen to launch. Besides, they recommend changing the registry down here and making it the default. So why make it the default here and not here? I've just had less trouble with that, and that's the way that I usually do it. That way I don't have to use the Anaconda prompt like they have on Windows systems. I will go ahead and install. Let's go ahead and fast forward through this. Okay, that's complete. Do next. I don't really want to learn more, so finish. All right, now MiniConda is installed, we hope. So we'll launch the command prompt, and we'll do most of what we're going to do now from the command prompt, and we'll launch Jupyter Notebook at a point. So let's go ahead and do conda. We can see conda is installed, so we do have MiniConda. I'm going to do conda install Jupyter. Now this installs Jupyter into the base environment. This is your base install of Jupyter that runs over top of all the sub-environments, even though the sub-environments will actually have their own Jupyters installed too. Now this does take a little bit, so I am going to go ahead and fast forward through this. All right, that is done. The next thing we're going to do is run that installation script that I gave you. It should be in your user directory. So there's TensorFlow GPU, YML. We're going to essentially run that. The command to run this and create your sub-environment with the right Python version for the current TensorFlow is in the description of this video and also on my GitHub repository. We're going to run this command here, but we're going to have to put a hyphen GPU in there because we're running it for the GPU. We'll run this. This does a lot of things, so this takes a while. Lots of things can go wrong while this is running, so be on the lookout for error messages as it goes through. I am going to go ahead and fast forward this. Okay, everything appeared to work just fine for me. Now, don't feel bad if you get errors. I actually went through this virtual environment 3 times before I got it to completely work as I expected. And of course, I recorded the one where everything worked perfectly to show you guys. If you get errors, Google them. Post them to the comments section here. I do monitor these. I haven't necessarily run into every weird hardware environment that you're going to deal with, but post them there. I can give you some information maybe, or other people reading through those comments might be nice and give you information. Now this next thing that it tells you, this is critical to do in Windows. Especially, you need to always conda activate the TensorFlow environment, so the environment we just created. On systems other than Windows, it's beautiful and you can run Jupyter and basically be in whichever environment you choose. But on Windows, Jupyter must be launched from whatever environment you're currently running on. So always keep that in mind. If you're only doing one environment, it's not going to affect you much. But if you try to import TensorFlow from inside of Jupyter and it can't find it, make sure you've launched Jupyter from that environment in Windows. We need to put TensorFlow into Jupyter, so this environment we just created. So we're going to do conda activate TensorFlow, and that lets you know that you're there. And then we're going to run this big hairy command. You shouldn't need to change anything there. Now, if you're doing this on a different version of Python, you may want to change that, but that's just the title, really. Paste that, and it lets you know it's now there. If you want to do a quick test to verify that TensorFlow is working, just run Python, and then do import TensorFlow as TF. If you get an error, it'll probably happen here. By the way, this little line that you see there, you don't normally see that, but that really lets you know that CUDA has now come online. And then print out version. You should see 2.0. At this point, things look really good. It should be installed and pretty much ready to go. Let's do another quick test. So on my GitHub repository, we'll go to my class. You may want to start it. You'll get updates to it because I keep this stuff very up to date. You should always look here before you install TensorFlow. I'll let you know if there's any gotchas that have appeared, and believe me, gotchas come and go. We'll download a zip file. I'm going to just unzip that to my user directory. I'm going to assume everybody knows how to zip and unzip, so I'm just going to fast forward through this. Okay, we're going to quit out of Python, and we're going to change into that directory that I just unzipped, and I'm going to do Jupyter Notebook. And again, make sure you're in the TensorFlow environment, or you'll get DLL errors, because Windows doesn't completely abstract that as well as it should. I bet they fix that in the future, though, in Anaconda. So you might not run into that issue, but it doesn't hurt. I do hate that I have to choose between all these versions of browser that Microsoft installs, Internet Explorer, Microsoft Edge. I bet they come out with Microsoft Corner next, but let's do Chrome. And then we'll go down to, or up to, Class 1. This will pop up. Just choose the environment that you just created. You always want to pick that, otherwise you might not have access to TensorFlow. So we'll set the kernel. If you need to do that later, you can just do change kernel and do it there, but make sure it happens and that you have your newly created kernel up there, or things will not work. Now the Colab code at the beginning, it wouldn't hurt if it ran, but we don't need to run it. So scroll to near the bottom and see this check code that I have. It has 2.0. Notice it says GPU is not available. This is just because that is the version that I had up on GitHub. This should flip to is available. So we'll run this. GPU is available. And that's the magic of this. Code that you wrote that's completely non-GPU aware will suddenly start running an order of magnitude faster. I could take you through a couple of demos of how fast that is, but I've seen things that take 30 minutes take a minute using even this GPU, which is definitely a solid mid-range GPU. All right, thank you for watching this. I hope everything went well and you were able to get this installed. If you run into some problems, go ahead and post those in the comments. I don't have access to a large array of GPU hardware, so I may not have run into what you're running into, but I'll do my best to answer where you might want to look at or other things. And if this kind of thing is interesting to you, please subscribe to my channel. Thank you.